Imagine a star so dense that a teaspoon of its material would weigh billions of tons. That's a neutron star. These stars are among the densest objects in the universe, second only to black holes. These incredible objects are the remnants of massive stars that have exploded as supernovae. When a star much larger than our sun reaches the end of its life, it undergoes a cataclysmic explosion, shedding its outer layers into space. The core of the star collapses under its own gravity. This collapse is so intense that it overcomes the repulsive forces between particles. This collapse crushes protons and electrons together. They form neutrons. The result is a star composed almost entirely of neutrons, hence the name neutron star. Neutron stars are incredibly small. Despite their massive density, they are only about 12 miles across, roughly the size of a city. They are only about 12 miles across. To put that in perspective, if you were to replace the sun with a neutron star, it would be no larger than a small town. But they are incredibly massive. A neutron star packs the mass of the sun into that tiny space, creating a gravitational field so strong that it warps space-time around it. They pack the mass of the sun into that tiny space. Neutron stars spin rapidly. Some can rotate several hundred times per second, making them some of the fastest spinning objects in the universe. They emit powerful beams of radiation from their poles. These beams are so intense that they can be detected across vast distances in space. These beams sweep across space like a lighthouse beacon. We call them pulsars. Pulsars are a type of neutron star that emit regular pulses of radiation, which can be used to study the cosmos. Neutron stars are fascinating objects. They challenge our understanding of physics and push the limits of what we know about the universe. They are laboratories for extreme physics. The conditions inside a neutron star are so extreme that they cannot be replicated on Earth, making them natural laboratories for studying the fundamental laws of nature. They push the boundaries of our understanding of gravity, density, and the nature of matter itself. The study of neutron stars helps scientists explore the behavior of matter under the most extreme conditions. These cosmic cannons stand as testament to the incredible forces at play in the universe. They remind us of the power and mystery of the cosmos, and the endless possibilities that lie beyond our current understanding. While typical neutron stars are mind-bogglingly dense, imagine one even larger, even more massive. Neutron stars are already some of the most extreme objects in the universe, with a single teaspoon of their material weighing about 1 billion tons. But what if we took this concept even further? What if there existed a neutron star so massive that it defied our current understanding of physics and astronomy? Enter the hypothetical supermassive neutron star. This isn't just a larger version of a typical neutron star, it's an entirely different beast. Imagine a star so dense and massive that it challenges the very limits of what we know about the universe. This theoretical object would dwarf its already impressive cousins. To put it in perspective, a supermassive neutron star could be several times the mass of our sun, yet packed into a sphere only a few kilometers across. The sheer scale of its density and mass is almost incomprehensible. It would possess a gravitational pull unlike anything we've ever encountered. The gravity of a supermassive neutron star would be so intense that it could bend light and warp space-time around it, creating phenomena that are currently only theoretical. The existence of supermassive neutron stars is still debated. Scientists are divided on whether such objects could actually form and remain stable, or if they would collapse into black holes under their own immense gravity. Their formation and properties remain shrouded in mystery. How could such a massive object come into being? What processes in the universe could lead to the creation of a supermassive neutron star? Some theories suggest they could form from the merger of multiple neutron stars. When two or more neutron stars collide, the resulting object could be massive enough to qualify as a supermassive neutron star. Others propose they might represent an exotic state of matter. This could involve forms of matter that we have yet to discover or understand, existing under conditions that are far beyond what we can currently replicate or observe. Regardless of their origin, the possibility of their existence raises intriguing questions about the limits of stellar evolution. What are the ultimate boundaries of star formation and collapse? How far can the laws of physics be stretched? The implications of a supermassive neutron star are profound. Such an object would not only challenge our understanding of stellar physics but also have significant effects on its surrounding environment. Its gravitational influence would extend far and wide, It would warp space-time, creating gravitational waves that ripple through the cosmos, potentially detectable by our most sensitive instruments. It would disrupt the delicate balance of star systems. Nearby stars and planets could be thrown out of their orbits, leading to chaotic and unpredictable cosmic events. Its presence would be a cosmic game-changer. The discovery of a supermassive neutron star would revolutionize our understanding of the universe, opening up new avenues of research and potentially leading to groundbreaking discoveries in physics and astronomy. The arrival of a supermassive neutron star in our solar system would not be subtle. Its gravitational influence would be felt long before it became visible. The first sign would likely be disturbances in the orbits of distant objects. Comets would be pulled from their icy domains. Dwarf planets would be sent careening off course. As the supermassive neutron star drew closer, these disturbances would become more pronounced. The outer planets, Jupiter, Saturn, Uranus, and Neptune, would experience significant orbital perturbations. Their once stable paths would become elongated and unpredictable. The delicate gravitational dance of the solar system would be thrown into disarray. One of the most immediate and catastrophic consequences of the supermassive neutron star's arrival would be the disruption of the asteroid belt. This region between Mars and Jupiter contains millions of rocky bodies. These asteroids range in size from small pebbles to dwarf planets. The immense gravity of the supermassive neutron star would act like a cosmic billiard ball. It would scatter asteroids in all directions. Some would be flung out of the solar system entirely. Others would be sent hurtling towards the inner planets. Earth would find itself in the crosshairs of a cosmic shooting gallery. As the supermassive neutron star approached the inner solar system, Earth's fate would hang in the balance. The gravitational pull of the neutron star would be immense. It could potentially eject Earth from the solar system entirely, condemning our planet to a frigid, lifeless existence wandering interstellar space. Even if Earth managed to stay gravitationally bound to the Sun, the consequences would be dire. The planet's orbit would likely be significantly altered. It could become more elliptical, leading to extreme temperature swings. Our familiar seasons would become a distant memory. The delicate balance that makes life on Earth possible would be shattered. The passage of a supermassive neutron star would leave Earth a profoundly changed planet. The once familiar continents and oceans would be reshaped by tidal forces. The climate would be unrecognizable. The delicate web of life that has evolved over billions of years would be decimated. If any life managed to survive the initial cataclysm, it would face a challenging and uncertain future. The altered environment would require remarkable adaptations. The once vibrant biosphere would be reduced to a shadow of its former self. The legacy of the cosmic colossus would be etched on the very face of our planet. The scenario of a supermassive neutron star entering our solar system is highly unlikely. Neutron stars are incredibly dense remnants of supernova explosions, and their presence in our cosmic neighborhood would be catastrophic. The gravitational forces alone would wreak havoc on planetary orbits, potentially tearing planets apart or ejecting them from the solar system entirely. The vast distances between stars make such encounters incredibly rare. In our Milky Way galaxy, stars are separated by light years, making direct interactions between them a rare cosmic event. This immense separation acts as a buffer, protecting solar systems from the gravitational influences of wandering stars. However, the possibility, however remote, serves as a stark reminder of the vastness and power of the universe. The universe is a dynamic and ever-changing place, filled with forces and phenomena that can both create and destroy on unimaginable scales. We are but a small planet, orbiting an average star in a vast cosmic ocean. Our solar system is just one of billions in the Milky Way, and the Milky Way itself is just one of countless galaxies in the universe. The universe is filled with wonders. From the birth of stars in nebulae to the violent deaths of stars in supernovae, the cosmos is a theater of both beauty and destruction. Black holes with their immense gravitational pull and galaxies with their billions of stars are just a few of the marvels that populate the universe. It is also filled with dangers that we are only just beginning to comprehend. Gamma-ray bursts, for instance, are among the most energetic events in the universe and could potentially sterilize entire planets. Black holes with their event horizons represent regions of space where the laws of physics as we know them break down. The contemplation of such cosmic events should fill us with a sense of awe and humility. The sheer scale and complexity of the universe remind us of our small place within it. Observing the night sky, we are reminded of the countless mysteries that lie beyond our reach. It should also inspire us to learn more about the universe we inhabit. Through scientific inquiry and exploration, we can uncover the secrets of the cosmos, gaining a deeper understanding of the forces that shape our existence and the potential for life beyond our planet.